Hello. Um, we're just going to continue with what we were doing earlier today. Um, we're gonna practice the sliding window questions, and my voice is not at its best. So if it gets worse, I might stop the stream halfway, and I'm having runny nose. Uh, but I thought I should do this anyway. So here I am. Let's move on. Let's not waste time. Okay, so this is the question. It is very similar to the previous question that we discussed um, in the previous video. It's all sliding window problems. Okay, maybe we can read the questions together and walk through. The longest substring with k distinct characters. So here, if you go back, the window size is not fixed like previous question. So here the window size was fixed, and here was not the case, and here that's not the case either. So we only need, what we need here is k distinct characters, and what's the longest sequence of character that you can get with two distinct characters. For instance, here's k is equals to 2. Character is more than two distinct characters. Okay, so one way to do it would be the brute force method, where we start with 0 and walk all the way to n minus 1, and that would be the outer loop, 0 to n minus what the hell, n minus 1. And then in the inner loop, what we do is we take the next character, so I plus 1 till n minus 1. You have to go all the way to there, and then figure out, we can keep a count of number of characters. As we loop through the inner loop, we can keep count of like unique characters. How can we keep count of unique characters? That becomes interesting. What we can do is we can store them in the dictionary, or if you know this is all alphabetical characters, what we can do is like create a dictionary size of 26 and then convert each one of them into the ASCII character numbers, and then increment, and that wouldn't be efficient. But so there'll be like brute force methods, outer loop from here to here, inner loop, the next character, and forward. No, the inner loop would start from I plus 1 to n minus 1. Yeah. So it'll start from here, get all the characters, and then as soon as it hits the 3 character, you break. So if in the inner loop, if the char count is more than k, you break, and then you keep track of roll maximum length that you have so far. Max length so far maybe equals to negative infinity, and then you can update it. So since it's maximum, we can just use negative infinity. So that would be the brute force method. Can we do better than that? Like similar to what we have done here, there's a lot of things that we'll be recomputing. Maybe we can start with A R A C I. So this is the thing, and then 0 1 2 3 4 5. okay, equals to 2, and this is the thing. Okay, so as we talked about, we can keep the character count in the dictionary. So in the brute force method, what we will be doing is keeping character counts in a dictionary. So there will be a dictionary that says, okay, A, the character count is 1. Once, and then we add R, we change the character count to 1, and then we keep on increasing. But and we check the length of the dictionary. Let's say this is the line of D equals to more than, okay, let's say more than K, we break. So that will be the brute force method, right? Okay. So that will be the brute force method. We'll be doing the same thing over here, but instead we will just use a pointer. And the pointer approach is the same. Like we will use a sling type window, like a dynamic window size, dynamic window, and then as we move out of the window, we decrement the values, and increment the increment that won't be entering. So in this case, if you want to walk through the algorithm, what we will do is, okay, the starting pointer will be here, and ending pointer, I guess, should be here, or? Yeah, starting pointer, ending pointer, yeah, can be here, ending pointer, so here, and what we can do is keep track of the things in the dictionary, the occurrences so far in the dictionary. So here we have start and end, and then length of dictionary would be empty. So if len d less than k, okay, so ideally, like in previous examples, the ending pointer will just increase. So what we can say is, while e is less than n, and if len of d is less than k, what we do, if it's the value is not here, I'm not sure about this, but what we do is, and okay, maybe not the most efficient implementation. Let's do something. If array e not in D star, okay, maybe what we can do is, I'm not sure what we can do. It's less than k, so we just have to store the occurrence. As long as the k is less than this, just store, or even if it's more than d, we need to store it. So we don't actually, this doesn't come yet, we don't have to deal with it. So what we do is, okay, as we move towards e, for each e, what we do is we d if e not, oh my god, array E not in D bracket E, now D bracket ARRE equals to 1. So includes the else, so the thing is already there, so we DARR E plus equals to 1, so we increment it, so this happens. And for every time we move the counter, the ending window, we move by 1, we do this. So we keep a dictionary of occurrences. I think I'm repeating a lot of things. I should probably speed it up. Like, I'm not sure how long have I been working on this. 11 minutes. Okay. That's long. That's long. Okay, so then we keep it in the dictionary. And then we need max substring, max longer substring equals to negative infinity. And then we do an if len of D more than K, what we do, we move the starting pointer. So we remove the value from ARR S minus 1 and so there'll be another line, so maybe I should just write it here. So if DARR S is equals to 0, you can delete it, delete DARR S. Maybe for this part I should probably use keyboard and type out the algorithms. This writing is not actually helping, and I'm not explaining the code here. What I'm doing is writing the real code instead of like going through and explaining the algorithm. And yeah, I don't know how to improve that part. Probably I should watch a lot more, watch videos of people explaining algorithms. I can't explain them without writing the code. So what we do is just decrement as if we are moving out of the window, decrement, and if it's gone altogether, we just delete it from the array. And then what? So and then decrement, and then we increment s by 1. Increment start pointer. The start pointer moves here. Yeah, I should be tracing. Okay, let's trace. So increment the start pointer. Start pointer will move here. End pointer will move and move here. R becomes R is 1. A is 1 at first, and then R1, and then when we move here, A becomes 2. The line of the dictionary is still less. Then we move to the third one. A becomes 3. Doesn't matter. And then we move to the next one. Okay, so before we move, before we move, um, we probably need to do it elsewhere. We can, yeah, we can. This is not the most optimal question. We can like remove the if and else. I can refactor the code later. But if len d equals to k, what we do is save the max sub. We update the max sub. Pick the max of ending minus start plus 1 over max sub. Okay, so we will update here, and then only we increase the window. So when the end pointer is here, end pointer start pointer will be still here, start pointer will be still here, and what happens is len equals to d equals to k, which is 2. As we are updating, there are only 2 characters, and then e minus e is 3 minus 0, and the plus 1 is 4. Then we max up becomes 4. Okay, so that, and then we don't do anything, so just increment. No, okay, so this one should go under this or in this, like inside this, not okay. So I think I knew this one is intended, the nation is not right. I think this is a bad, horrible way to explain things to people. But I hope you're not watching it for the content. Okay, so we do that, and then what? Yeah, I lost. We should avoid meta talks about these streams and stuff. Just focus on the thing. Okay, so this is here, and then in the next, okay, oh, so we forgot to increment, and then this is only increment if this condition is met, but normally outside here we can do e plus equals to 1. Once this is done, e plus equals to 1. So here we are only moving in and out of like 1, so there's not really a minimization issue. We can just keep on moving the start pointer. That's the while loop here. Unlike here, there's like 2 while loops, because we need to minimize, so the end pointer starting pointer have to be small. We have to shrink the starting pointer as well as the increase the end pointer. So that's not the case here. So we don't have to do 2 loops. So and then we move the end pointer. Let's trace through, continue trace through. So end pointer goes here, and then the thing is the value is not here, so this stuff updates, and then the dictionary size becomes C1, and then A3 C1. The size becomes really large. That's what she said. Okay, my throat is killing me. So C is 1, and then this condition will be true. Len of D is more than K, is because now the size of D is 3. So we'll be hit this, and then we try to decrement the starting pointer, which is A. Actually, we need another loop here. I was wrong. as always. Actually, maybe not. Wait, I'm too soon to judge. Uh, so if we decrease, yeah, we need another loop. So if we decrease start pointer to here, so this is what it does. It decreases the start pointer by one. So no, it's supposed to increase start pointer by one. So start pointer becomes here, and we minus. So A is 3, R is 1, C is 1, right? So because of this process, A becomes 2. A, give me a second. I've been talking to myself, haven't I? I muted the thing here when I was blowing my nose and I forgot to unmute it. I don't know where you guys lost me or I muted. I think we were pretty much near the end. Uh, so it's just some optimization since we have this while loop. We need a while loop. I think I'm not sure we explained this. We need a while loop because it's not sufficient. Even if you remove just one character, let's say if you remove this one, not character, yeah, one character, it's not gonna. It's only going to decrement the frequency from 3 to 2. So the total number of unique characters is still going to be ARC is going to be the same. So what we have to do is we create a while loop until, and then we loop until we meet this criteria where the total number of items in the dictionary is less than k. So it will do the decrementing removing part. This is basically a sling like thing. The tail just keeps on trying to try to follow the condition, and then yeah, I think that's about it. It should be pretty straightforward. All right, not feeling well. I'm gonna get some rest. Perhaps I should have done the stream tomorrow instead. But I don't want to break the streak. So here I am. Thank you. No, I'm not even showing you the code. I was just talking to my. Forget it. Forget it. Just go to sleep. Bye.